Hello, good afternoon. My name is Hafiz, and today I'll be presenting a comparative analysis of Type 1 and Type 2 hypervisors, which are essential components of modern virtualization and cloud computing. All right. So the agendas and topics I'll be covering will be first I'll go give a brief introduction to hypervisors and why they matter. Then I'll cover some background concepts in virtualization. Later that, we'll look at the differences between Type 1 and Type 2 hypervisors, including their architecture, performance, and security characteristics. We'll also explore typical development scenarios, and finally, we'll wrap up with the main takeaways. Here's the introduction. Hypervisors are a backbone of virtualization, which is a foundational technology in cloud computing. A hypervisor, also called a virtual machine monitor, is a software layer that allows multiple operating systems to run on the same physical hardware simultaneously. This makes it possible to consolidate servers, run isolated environments, and improve resource usage. There are two main types: Type 1, also known as the bare metal hypervisors, and Type 2, known as the hosted hypervisors. Type 1 hypervisors run directly on hardware, while Type 2 runs on top of an existing operating system. To give some understanding to hypervisors, it's important to know how some fundamental concepts. In 1974, Popek and Goldberg published a formal theory of virtualization. They stated that for an architecture to be virtual, uh, virtual, virtualizably sensitive, instructions must trigger a trap to a higher privileged layer, which in this case is a hypervisor. This is known as a trap and emulate. It means that whenever a guest operating system tries to do something that could break installation, the hypervisor takes control and emulates the required behavior safely. Early x86 processors were not designed with virtualization in mind, which forced companies like VMware to rely on techniques such as binary translation. Later, Intel and AMD added hardware virtualization extensions, which are VTX and AMD uh, hypervisor design, and greatly improved performance. These improvements made hypervisors practical and efficient on commodity hardware. Hypervisors and their types. Rosenblum and Garfinkel, two pioneers of modern virtualization, described the hypervisor as a thin software layer that exports a virtual machine abstraction. That's on quote. In simple terms, it behaves like hardware so that software doesn't know the difference. Today, hypervisors fall into two categories. Type 1, which is bare metal, that runs directly on physical devices, replacing the traditional operating system at a lowest level. Then there's Type 2, hosted, runs as a normal application inside a local operating system like Windows, Linux, and Mac OS. So here's a type 1 hypervisors and a simple diagram to explain it. Because they control the CPU memory devices directly, they can offer near native performance, strong isolation between virtual machines. These include Zen, VMware, VMware ESXi, and Microsoft Hyper-V. These hypervisors are typically used in enterprise data centers, cloud providers, and production server environments. In this, hold on, sorry, in this diagram at the bottom is the hardware you can see, top actually, sorry. Above it sits the hypervisor, which manages CPU, memory, network, storages. And on top of that is the hypervisor. We have one of the guest operating systems and final applications running inside these guests. Here's type 2, the hosted variant. In this architecture, the hosted OS manages drivers, scheduling memory, and I/O. This means type 2 hypervisors easier to use and more flexible. Also, it introduces an extra layer that adds overhead. Sorry. Popular examples include VirtualBox, VMware workstation, and parallel desktop. These are great for developers, students, software testing, and everyday users who need to run multiple operating systems on regular laptop and desktops. Yes. So, architectural differences and performance of Type 1 versus Type 2. Uh, in contrast, the Type 2 architecture adds an extra layer. The hypervisor is not directly on the hardware, instead, it is installed inside a host operating system. The host or operating system interacts with the hardware, and the hypervisor interacts with the host. This means more layers, more overhead, and more potential points of failure. But also, on the contrary, easier installation, better compatibility, and more user friendly. This is why Type 2 hypervisors are ideal for personal and educational use. Uh, Architectural difference. Uh, let's state a couple of quick examples. For placement, Type 1 is directly on hardware, whilst Type 2 is on top of a host operating system. And privilege, Type 1 has the highest privilege, whilst Type 2 has less control because it works through the host. Performance-wise, Type 1 performs better due to fewer layers, and same as for security, Type 1 has a smaller attack surface. Whilst in ease of use, Type 2 is better and easier for beginners because it behaves like a normal application. So security. Security is another major factor. Type 1 hypervisors are visually more secure because they have a smaller trusted computing base, meaning fewer components that can be attacked. There is no general purpose operating system underneath that could be compromised, and they can use hardware features like IOMMUs to isolate devices. Type 2 hypervisors, however, depend heavily on the host operating system. If the host operating system gets compromised, all virtual machines running on top of it are at risk. This makes Type 2 hypervisors less suitable for multi tenant or sensitive environments. Deployment scenarios, conditions, and use cases. So, where do these fit Type 1 and Type 2? When it comes to Type 1 fits in data centers, platforms like AWS, Amazon's AWS, Azure, Google Cloud, or high density VM hosting, or also security sensitive environments. For Type 2, developers needing multiple operating system environments would be one example. Students practicing Linux, networking, or operating system concepts, or maybe in smaller labs and general home uses. Hybrid and nested virtualization. Sometimes environments mix the two. For example, CI pipelines that run a Type 2 hypervisor inside a Type 1 hypervisor. But usually, or generally, Type 1 remains the standard for large scale operating systems. How to choose between Type 1 and Type 2? In terms of performance, if you need high performance, Type 1 is your way. So as for security, for convenience, it's best to take Type 2 because it's something easy to use and install. And going back to Type 1, hardware wise, also, it's leading. And I would give a quote that this is no universal best hypervisor. The best choice depends entirely on your workload and environment. Closing words for conclusion. Type 1 and Type 2 hypervisors each have distinct advantages and trade-offs. For Type 1 is ideal for cloud platforms, data centers, and high-performance scenarios, whilst for Type 2 is ideal for developers, testing, and educational environments. Both types are essential and widely used, and the choice between them is not about superiority but about suitability. Thank you for listening, and yeah, that's it.